Hello everyone. Today we want to look at randomness. We want to answer the question, what is a random experiment or what is a random phenomenon? So we started by defining a random phenomenon. So we define a random phenomenon that an experiment or a phenomenon is random if individual outcomes are uncertain, but there is a nonetheless a regular distribution of outcomes in a large number of repetitions. So the key is individual outcomes are uncertain. Naturally, we have processes that occur naturally. We have that we simulate some processes, but processes that occurs or phenomena that occur, if their outcomes we don't know for sure which outcomes will occur, we call such phenomenon random. We are going to illustrate with an example here. For example, this an example. In this example, we are going to look at the concept of experiment. What is an experiment? What is an outcome? What is event? And what is randomness, or what is random? Now, when I talk about experiment, I mean the phenomenon in this question is that we are carrying an experiment. A phenomenon can be a natural process, or scientists carrying experiment, or statistician carrying experiment. Now, this is our question. Suppose a coin is tossed once and we calculate the probability of observing head. So we want to toss a coin, and after we toss a coin, we want to calculate the probability of observing a head. Now we normally define an experiment as the action or the process that results to outcomes. So if you carry an experiment, there is something you expect to happen. If a natural process occurs, we always have a result of that natural process. For example, if a mountain erupts, there is a result. Some forest is destroyed, some structures are destroyed. This is a result of a process. So naturally, majority of the processes that occur, we normally don't know for sure the outcomes. We might know all the possible outcomes, but we might not know exactly which one among many. So we say the experiment is the action or the process that results to outcome. So in this our example, the action is tossing of a coin. We are tossing a coin. That is our action. We are tossing a coin. And because we are tossing a coin, that becomes our experiment, because it is the action or the process that is occurring. So our experiment is tossing a coin. Outcome is what we expect to observe in the process of carrying out the experiment. So when we are tossing a coin, what is in our mind? What do we expect to observe? So when we are carrying this experiment, we are expecting either to see a head or a tail. So the two possible things we expect to see, it is a tail or a head. Do we expect to see a 6? No. When you toss a coin, you don't expect to see a 6. A coin does not have a 6. Do you expect to see a hen? No, you don't expect to see a hen. When you toss a coin, you don't expect to see a hen. So what we expect to see, it is head or tail, and these two things is what becomes our outcomes. The correction of all possible outcomes is what we normally call sample space. Some books call it aggregation of all outcomes. So whatever we expect to see, or when we collect all possible outcomes together, we normally have a sample space. It is normally denoted by capital S. Event is what we are interested in. So in a question, there will always be, in a question that you are asked, or in a scenario, there is always something that you are interested in. For example, in this question that we are looking at, we are interested in calculating the probability of observing a head. So the event is observing a head. So whenever we observe a head or a head occurs, we say our event have occurred. And it is crucial to note that event is always a subset of a sample space. Event is always a subset of a sample space. Again, because our head, it is contained in our sample space. You can see we want to calculate the probability of a head, and it is contained in the sample space. Now, apart from all that, we want to answer the crucial question of this video. Can you be able to know if a process, an experiment, a phenomenon is random or not? Now, we want to ask ourselves, is tossing of a coin random? Is this phenomenon of tossing of a coin random? Now, before you toss a coin, you know that when you toss a coin, a head or a tail will appear. But we don't know for sure. We really don't know. And this is the thing. We really don't know. Either a head will appear before you do the actual tossing. So in my mind, before I toss a coin, I know a head or a tail will appear. But before you do the actual tossing, you don't know if a head appears or a tail appears. That uncertainty in unknowing which outcome will appear is what makes a phenomenon, an experiment, to be random. And this is what we are saying. Tossing of a coin is a random experiment. Why? Before you do the actual tossing, you don't know if a head will appear or a tail. You can only guess a head will appear or a tail. Yes, we know the outcomes. All the outcomes is either a head or a tail. But you don't know which will appear before you do the actual tossing. That uncertainty in unknowing the outcome before you carry the experiment is what makes an experiment or a phenomenon to be random. Hence, tossing a coin is a random experiment. These three exercises here, part A, B, C, are meant to explore if you understand what is a random experiment. I will do part C, and maybe you can try part A and B. I'll give the answers of part A and B in our next video. So in part C, the question says a coin is tossed. We know when we toss a coin, the sample space of tossing a coin is head and tail. So this is the sample space when we toss a coin. And we are interested in calculating the probability of a head appearing. Now, another information is added. The coin is biased such that tail have probability 0 of happening. So when we talk about a tail have probability 0, probability of a tail happening is 0. What does this mean? It means we are certain tail will never occur. That means whenever we do this experiment, a tail will never occur because we are told the probability of a tail occurring is 0. That means whenever we toss this coin, we always be expecting to observe a head. That means even before we toss a coin, even before we do the experiment of tossing a coin, we already know a head will appear with probability 1. Hence, this phenomenon or experiment or process is not random. Why? We are for sure the possible outcomes are head and tail. We are sure whenever we do the tossing of a coin, a head will always appear. That certainty in knowing which outcome will always appear is what makes this phenomenon, is what makes this process not to be random. The last part is, what is a probability theory? We need to answer this question. What is a probability theory? A probability theory is a branch of mathematics that studies or describes random phenomenon. Already you know what is a random phenomenon or a random process. Now, the branch of mathematics that is dedicated in studying random phenomenon is what we call probability theory. What is a probability model? A probability model, whenever you are carrying a random phenomenon, you have sample space, you have sample, you get a sample, then say for example a head and a tail, then you have probability of a head and a tail. So we normally say sample space contains outcomes, and you have the probability of these outcomes, probabilities of these outcomes. Then we normally say probability model is the correction of outcomes together with their probabilities. So one crucial thing is it should be a random phenomenon. Two, the outcomes should be accompanied with their probabilities. When we have these three scenarios that a random phenomenon have occurred and their outcomes are accompanied by their probabilities, then that describes a probability model. So if you are told to describe a probability model, it is enough to describe the outcomes together with their probabilities. Today we are going to stop at that point. Next class, we are going to look at random variables. Random variables. And we are going to describe what is a variable and what makes a variable to be random. Then from there, the third class will be now introduction to stochastic process. We are going to do introduction to stochastic process. If you have any question, you can email me or you can find me in Facebook. I will all answer your question regarding statistics, stochastic process, random processes, and randomness. Let us meet next class, and hope you enjoyed the video. Subscribe. We are going to do a lot in stochastic process.